Happy Thursday, everyone. First, want to apologize that I'm not there today. I had all intentions of being there, but something came up that was, not really planned. So I had to take the day off, and I hope that you guys are still able to learn what we're going to do today. We'll definitely discuss it more on Monday to make sure you guys are in good shape going forward. But anyways, I want to remind you what our homework was last night and make sure that you were able to do that. Remember, that is due today. So if you didn't already, please put it in the folder. If you had already done it, it's in the folder. You're welcome to get it and check it. If you don't mind, though, put it back in the folder because I was going to go ahead and enter those tonight, but just ran out of time. So anyways, make sure you turn them in. But anyways, here's numbers 1, 2, 3, and 4. I tried to color code those. So if you took a picture of them and really kind of dove in there and look at them, you would be able to figure out where all of those specific values were coming from. So anyways, number 1 had a vertical stretch. And since that 9 was on the outside, it is what it is. So it's shifting down 9. On number 2, it had 3 transformations. You had that negative out front. So that means it had to reflect over that x-axis. That positive 5 is inside, so it's the opposite. So that's why it's technically a negative 5, meaning it shifts left 5. And then you have that positive 3 on the outside. It is what it is. So that's representing a vertical shift up. And I should have put 3 there and did not. Now it's there. And then, of course, number 3 and 4 were like the 2 that we did yesterday where they write the descriptions of what your transformations were and you write your equation. So the first thing to point out is what kind of function it is. Number 3 was square root. Number 4 was cube root. So make sure you note that. On number 3, it first tells us that it's vertically compressed. So remember, that means it has to be a value between 0 and 1, and 1/3 is between 0 and 1, so I put it out front in A's position. Then it says it's translated so that the endpoint is at 4, -1. So hopefully you remember that means that 4, -1 is our H, our horizontal shift, and our K, our vertical shift. So that's a positive 4, so we know that inside, it's going to be the opposite, so we put -4. And then on the outside, it is what it is, so that -1 is how you write it. And then finally, number 4, it's a cube root function. It's reflected across the x-axis, so there's that negative. It's vertically stretched by a factor of 3, so that is that A value out front. And then it says it's translated 8 units down. So remember, that needs to be on the outside, and it is what it is. So -3 times the cube root of x, and then outside of that, -8. So hopefully you were able to get all 4 of those correct. Now you should. So you should have all that worked out. Here's the graph for number 6. I want you to notice, and hopefully you did notice this when you were doing it, right here. That's telling me that it's shifting left 2. There is no vertical shift here. So that's why that thing is not going up, not going down. It's just shifting to the left 2, which you can see right there. So then I graphed the rest of it in my graphing calculator, which I hope that you were able to do on your own and come up with a couple more points like I did. And therefore, you see that this graph, unlike the ones we did in the examples yesterday in class, this one is going down, okay, because it was reflected. So that's the first one we've seen like that. Now, as far as the domain goes, it doesn't affect it because it starts at -2 and it goes off to the right. However, with the range here, that's a little different than the ones that we looked at. And here's why. It's going down on the y-axis. So remember, we always put our smaller value first, and that's why I put that it's going from -infinity up to that 0 value on that y-axis, and that's as high as it will ever go. So there you have it. Hopefully you guys understand where all that came from. The end behavior, pretty straightforward. You see that it's decreasing, so there's the graph for number 6. You were also supposed to do 2 on the back, and both of these ended up being very similar to each other. In fact, if I had it to go over again, I maybe would have given you maybe like number 8 and 9 instead of number 8 and 10, because I would have liked to have seen a cubic function that also had a reflection. But anyways, hindsight's 20/20, right? But anyways, as you notice here, if you look at this -1 inside, that means it shifted right 1. There is no vertical shift, so there's where your point of symmetry ended up, correct? And then, of course, with your graph, picking a few more points, you were able to graph hopefully the same that I graphed. And here are all the values. Domain and range are both negative to positive infinity, just like we talked about yesterday and the day before. The end behaviors are pretty straightforward. And again, since this one's going up for the whole graph, it's increasing only, and it's increasing from negative infinity to positive infinity. And again, like I said, one of my disappointments for last night's homework assignment is number 10 was very similar to that. It just stretched out a little bit, and instead of it shifting to the left or right, it only shifted, because that's on the outside, it only shifted up 5. So that's the only real difference. But as far as the graph goes, and then everything but the point of symmetry, pretty much is exactly the same as what we did up there on number 6. So, again, kind of a disappointment that I didn't use a different example. If I had to go over, I definitely would have. But anyways, if you need to go back to one of these that were answered to look at it, just ask the substitute nicely. I'm sure she would get it to that point and pause it. But we are going to, with the video, move along, and I'm going to teach you how to do inverse functions today. So if the sub has not already, you should be getting the note sheet for your inverse functions. And we're going to begin. Now, again, a lot of times with these notes, there's a lot of words, a lot of reading. But there's a couple things that you need to know in order to have a really good understanding of what an inverse function really is. You see, to be a function, there's something specific that it has to do. And I'm going to show you that here in just a few minutes, or a couple of minutes. But basically, in a nutshell, here's what you need to know. To be a function, what happens is you have some type of equation. And in that equation, like that 2x plus 1, if I wanted to figure out what the solution to that function is, if we treated x as 3, what we do is we treat 3 like it's an input. And we go to our equation, which was 2x plus 1, and we enter 3 into x's position, and we solve to get what we call an output. So an input gives me an output. So when I plugged 3 in there, I went 2 times 3, that's 6. 6 plus 1, that's 7. You see, no matter how many times I plug the value 3 into that function, it's going to give me the same output every time. When I plug -2 into that same equation, it's going to give me the same output every time. 2 times -2 is -4. -4 plus 1 is -3. When I plug 5 into that function, no matter how many times I do it, 2 times 5 is 10. 10 plus 1 is 11. Every input will give me only one output. Okay? So that is what makes something a function. I can't plug 3 in this time and get 7, and then plug 3 in another time and get 18. That's just not possible. An input cannot give you multiple outputs. Okay? If an x gives me multiple y's, it's not a function at all. So anyways, we've kind of talked about that in the past. I hope you understand it. But here's the whole concept of an inverse. if you come on down here, what we read is this. F is acting on the numbers and transforming them, and that gives us our values. Well, an inverse function will actually undo what F did. So the inverse of F needs to be able to take this 7 value, and when I plug 7 in, it needs to be able to turn my answer back into the 3. And when I take that -3 into that same function, and then I move it and I plug it in, it's going to give me the output of -2. When I plug 11 into that inverse, it's going to give me the output of 5. So what happens is an inverse will undo what the original function did. I hope that makes sense. That's what we're trying to find when we're finding the inverse of a function. We're trying to find the exact equation that will undo what the original equation did. I hope that makes sense. But anyways, not all functions, if you read here, not all functions actually have inverses. In order to check to see if a function even has an inverse. So there's no reason to waste your time trying to find an inverse if something doesn't have an inverse. So in order to check to see if a function has an inverse, we got to use this thing called a horizontal line test. A horizontal line test. Now, I don't know if you remember, but if we wanted to check to see if something was a function, we did this thing called a vertical line test. But if we want to find out if a function has an inverse, we actually do a horizontal line test. It works the same way. You just run your line horizontally across your graph, and you determine whether or not it touches more than one spot at a time. If it does, then it is not going to have an inverse. That is what you do in order to determine whether something has an inverse or not. So what we're going to do is we are going to use that horizontal line test, like I just said. In order to determine if the inverse function actually exists. If it passes, only if it passes, what we're going to do is, with our original function, we're going to switch x and y. And once we switch x and y, we're going to now solve for y. And in doing that, when we solve for y, it will actually go through the process of undoing my original function. And once it undoes my original function completely, you have the inverse of that original function. So we replace y at the end with f of -1x, and f of -1x is what indicates that it is the inverse function. Now, there's a step number 5 that's a little more confusing. Sometimes when you do have one that passes the horizontal line test, and you go through the process of rewriting it as an inverse function, you have to check that inverse on the calculator to make sure it will reflect over the original function. And sometimes, if you notice that it won't, you have to restrict the domain. And that's a little complicated. It might be something that I need to cover a little bit more in detail come Monday. So let's do what part of this is easy. I will address that, but let's do the part of this that I know without a doubt you will understand, okay? So I'm going to do this a little bit differently. We're going to go through several of these problems, but I don't like a couple of the functions that I have to use with my graphing calculator. I don't like the one on here very much. So I'm going to switch over to my camera, and I'm going to use the calculator here that I brought home and show you this. So let me show you first of all 3x minus 4. And I'm going to switch over here to the camera. And I'm going to graph 3x minus 4. Okay, and I graph this thing. And what I'm going to do is, with my pencil, I'm going to do a horizontal line. Now think about this, guys. If I run this horizontal line up this entire graph, do I ever touch more than 1 point at a time? Look, I'm only always touching 1 point on that graph. Therefore, it passes the horizontal line test. So what does that mean? Well, that means it can have an inverse function. So this one, it checks out. We can find the inverse for this equation. So here's how we do it. We switch x and y. Well, if you're looking at this thing like I'm looking at it, it doesn't even have a y. Or does it have a y? Of course it does. You guys all know that f of x is just another way of saying y. That's a y equals 3x minus 4. That's what that's saying. So we're literally going to take this y and this x and we're going to swap them. So we're going to rewrite this equation where it says x equals 3y minus 4. Now, why in the world would I do that? Because if I now go through the process of getting this new y alone, it's going to undo what my original function did. And that is what an inverse function is. It undoes the original function. So how would I do this? How would I solve for y? Well, hopefully you guys see the first thing you're going to do is you're going to add that 4 to the other side. So x plus 4 equals 3 times y. Well, what's the last thing I do to get y alone? I'm going to divide by 3. And at that point, y is now alone. So if I go back to my notes real quickly, what does it say that I do after I solve for y? It says replace y with f of negative 1x. So at this point, I'm going to say, since I finally got y here alone, I'm going to switch that y to f of negative 1x equals x plus 4 divided by 3. Okay, now let me show you something real quickly on this graphing calculator. Let's go back to our camera. And let me now graph with this one, okay? Don't erase it, but let's graph with this one the inverse function. So go down here to y2, like I've done, and I want you to graph this new function, which is a fraction. So alpha y equals, number 1. And then in the top, we're going to put x plus 4, and on the bottom, we're going to put 3. This is the inverse to that original function, and we're going to graph it. Now, I want to show you one last thing. Do you see how this function and this inverse are? A function and its inverse will always reflect over the line y equals x. Okay, y equals x is just a diagonal line that cuts right through here. So if I were to graph, for example, on y equals, if I were to do a third graph, and I know it's getting a little out of control, but I want you to notice, see how that line cuts right through the middle of those two graphs? It is a perfect reflection. So sure enough, I know that I did all this right because that fits the characteristic of an inverse. It reflects over the line y equals x. Let's go back to our notes. And let's look at another problem or two. I'm probably going to do more than one or two. But let's start right here with B. Again, I just cleared my calculator. I like to clear it out some because we're going to go and we're going to graph this new one, and we're going to check to make sure that it has what we call a inverse. So we go to y equals, and we type in cube root of, so that's math number 4, and then we're going to put the original x minus 2. We're going to graph it. Now, we just dealt with cube root functions, so you kind of get an understanding of what those look like. But if I run a horizontal line up this whole thing, do I ever touch more than 1 point at a time? Now, that's kind of a tricky one here. And the reason it is, you see how these look like it's just one straight line, one straight line, one straight line? You got to remember, this thing is gradually going up. It's just going up at such a slow change that it almost looks like it's a dead flat line, but it's not. So this thing is constantly going up. So there's really no time where I'm hitting the same point at the same time. So therefore, this one actually does pass the horizontal line test. So this one passes. It is going to have what we call a inverse. So here we go. What do? Well, we switch x and y. Remember, this is y. So we're going to switch them. We're going to say x equals the cube root of y minus 2. And we're going to do what? We're going to solve for y. Now, to solve for y here, we've done this recently at the very end of last 9 weeks. Are we ready to get rid of that minus 2 yet? And I didn't mean to mark it out like that. Thought I still had the highlighter. Of course I'm not. You got to get rid of this cube root before you're able to get rid of that minus 2. So does anybody remember how to get rid of a cube root? I hope that you said you have to cube both sides. You have to cube both sides. When you do that, that cube root and that cube will cancel, and here's what it'll leave me with. It'll leave me with x cubed on the left side, but on the right side with those canceling, all I'll have left is y minus 2. Now, am I allowed to get rid of that minus 2? For sure. So I add 2. So x cubed plus 2 equals y. So what's my last step? I need to change that y to f of negative 1 x. That's indicating that it is an inverse. And that equation is x cubed plus 2. So let me show you this in the graphing calculator. We're going to do two things. I'm going to not only go in here and rewrite this equation as x cubed plus 2, but I'm also going to do x. Because why? Well, remember, y equals x should cut those two graphs right in half. So there's my inverse, and sure enough, do you see how they would be symmetrical over that line? They absolutely would be. So there you go. Sure enough, we got all of those right. We solved for our inverse function correctly. So voila, that one's done. Okay? All right, let's go back and let's look at another one. I'd like to look at C real quick, and this one will be a pretty fast one because what's the first thing we need to do? A horizontal line test. All right, so let's go back to our graphing calculator. I know this is a little tedious, but we're going to type in here, open parentheses, x minus 4, close parentheses, raised to the alpha y equals, number 1, 2/3. So there's our equation. We've typed it in correctly, and here comes my graph. Took it a minute, didn't it? But I want you to notice something. If I do the horizontal line test, does it pass? Or does it touch multiple points at the same time? Look at all that. It's hitting 2 points at the same time. So what does that mean? It means that this one does not pass the horizontal line test. This one fails, okay? So what does that mean if it fails? It means it has no inverse. No inverse. Okay? No inverse. All right, let's go over here to letter D. There's something significant about this. Up to this point, we've never seen what we call a condition. You see, they want me to graph x minus 1 to the 4/3, but only for the values of x that are greater than or equal to 1. And y'all probably never, ever seen how to do that. Maybe you have in Algebra 1, but I doubt it. So I'm going to show you how to do that now. So let's get our calculator back out. I'm going to go back to my camera. And I'm going to go to y equals, and I'm going to eliminate that. And I'm going to type this one in. Here we go. We go open parentheses, x minus 1, close parentheses, raised to the alpha y equals, number 1, 4/3. But I want you to notice, if I graph it just like this, give it a minute, will it pass the horizontal line test? Absolutely not. However, that's not what it wanted me to graph. It wanted me to put a conditional on this thing. So here's how you put a conditional on a function in your graphing calculator. Once you've typed in the correct function, so x minus 1 to the 4/3 power, we're going to put the conditional in by using divided by, and then we're going to open up a parentheses, and we're going to tell it it's for all x values. Now here, watch this one. Then we're going to do, watch my finger, we're going to do second math, and we're going to pick the inequality that they tell us, which is number 4 greater than or equal to 1. So did y'all notice how I entered that conditional? That's how you do it in a case like this. So what it's going to do is it's only going to graph this function for the domain 1 to infinity. So when I graph this thing, does the portion that they specifically want me to graph, does it pass the horizontal line test? Absolutely. So for this portion only, it wants me to go ahead and find my inverse function. So here we go. We switch x with y. Remember, this is y right now. We switch x with y. And then we solve for y. That's how we do it. And this is easier than you think it is. Okay, so the first thing we got to do is we clearly have to get rid of that 4/3. So please remember that being a fractional exponent, we're going to get rid of that by raising it to the power of its inverse, 3/4. That's how you get rid of a fractional exponent. You raise it to the power of its inverse. So x to the 3/4 power equals y minus 1, because these simply cancel out. So when we do that, the last thing we're going to do is add that 1 over here. So sure enough, y, or what we call f of negative 1x, because this is the inverse, it will equal x to the 3/4 plus 1. Now, I want to go back to my graphing calculator, and we're going to make sure that what we just came up with, sure enough, is the inverse to that original. So leave the original alone with its conditional there and everything, and now type in x to the 3/4, and then what was it? Plus 1. Nope, look what I did wrong. I put the plus 1 up in the exponent. I need to scroll down here and put the plus 1 down on level. So be careful with that. And now let's see if those, in fact, would reflect over the line y equals x. Remember, y equals x comes up this direction. So sure enough, it would cut it right in half. So we found the inverse function. I hope you understand that. It's not overly difficult, but it does have some tricks to it, okay? But that's how you find the inverse. We're going to do one more. I would encourage you to graph this one. And the way you do it, in fact, let me just show it to you. We got time, I think. The way you graph, and let me just reset the whole calculator. That's how I like to do it. It's real fast. If I go back to y equals, to do what those are called absolute values. You're going to go to window. No, I'm sorry, dum-dum. You're going to go to alpha window, and number 1 is absolute value. So you're going to go to y equals, and you're going to do alpha window, number 1, And you're going to type inside that absolute value x minus 4, and then scroll outside of that and put your plus 5. And when you graph it, it's a V. Does a V pass the horizontal line test? Absolutely not. So this one has no inverse. No inverse. Okay, I'm going to do one more with you. Letter F, and then I'm going to give you a few homework problems tonight. This will be due on Monday. So you'll have tonight, you'll have Friday to work on this. If you have any questions, you can reach out to me Friday. But let me finish this thing off by doing another one where we have to put a condition. So here we go. Let's go back to our graphing calculator real quickly. And let's type this thing in. We've got open parentheses, x plus 3, close parentheses, squared, plus 1. And that's all of the equation, but we want to now add our conditional. So we push divided by, and in parentheses, you need to put your conditional, and it is x is second math, and it's less than or equal to negative 3. So we entered our conditional along with our equation, and we're going to graph this thing and see if it passes the horizontal line test. And sure enough, because we cut it off right here, you can see that it does. So this one is definitely going to have an inverse. So here we go. We're going to switch x and y. Remember, this is a y. We're going to switch x and y. So x equals, open parentheses, y plus 3, close parentheses squared, plus 1. And now we're going to go through the process of solving for y. So first, what's furthest away? That plus 1. We're going to subtract it. Now, I can't get rid of this 3 inside until I get rid of this 2 that's an exponent outside. So how do I get rid of squared? What's the opposite of squaring? You got to take the square root of both sides. That means you have to take the square root of the entire thing, x minus 1. Now over here, it leaves me with y plus 3. So the last thing I'm going to do is I'm going to subtract that 3. So can that go inside that radical? No, sirree. So my inverse, so f of negative 1x, equals the square root of x minus 1 on the inside, and then minus 3 on the outside, okay? That'll be your horizontal shift. This will be your vertical shift. That's why you don't combine them. You leave one inside, you leave one outside. So let's go graph this thing and see if, in fact, it is the inverse of that original function. Last thing, last one. So let's check it out. Let's type in the square root, we know is second x squared of x minus 1. And then we're going to scroll outside of that and put our minus 3. And then we're going to graph it. Now again, a little harder to see. Is that an inverse? I don't know if it is. Let's look at this line. If we put the y equals x, did I make a mistake somewhere? Minus 1 square root minus 3. Let's look at the y equals x, and let's just see if it reflects over that point. I don't think it does. Let's see if I type something incorrectly. Plus 1, x is less than negative 3. You know what? I bet you $1 million. This was probably not supposed to be less than. I'm sorry, you guys are getting tagged around. I bet this was supposed to be second math. I bet it was supposed to be greater than or equal to. Now let's look and see. There it is. That's what it was supposed to be. So what I need you guys to do is on F, you need to change this, and I don't have a pen on me right now. I need you to change this to greater than or equal to -3. In fact, let me just go back in here. This right here needed to have been x is greater than, and then it would have, in fact, been the inverse. So very good. Sorry about that. I don't know what the mistake was there. But anyways, that is how you do it. I hope that you guys understand. I hope you try with real effort your homework tonight. So here it is. If you haven't gotten it yet, it'll be passed out now. But I want you to do 1, 3, 5, 7, 9, and I want you to do another one that has a conditional, number 4. Okay, so that's 1, 2, 3, 4, 5, 6 problems. That's not that big of a deal. Let me remind you, I know you might be almost out of time and not able to use a calculator here for this assignment, but on your Chromebooks, you all have the TI-84 Plus available to you. So please use it and check to see if these are going to work. I will tell you, 2 of these on the homework do not have inverses. So you're really only going to have to work out 4 of the problems. 2 of them, after you graph them, you'll see they don't have inverses. So give this a try, and we'll see you on